Hi everybody, and this is Mr. Ege. This is a STEM design class rocket project. And we last video we just created this rocket 3D rocket solid model using 3D Studio Max. Okay, and we just simply took a break after finishing the 4 fins of the rocket, nose cone, and the body of the rocket. Now, today we're going to assign mass, the weight of the rocket, and also we're going to assign the quality of having a mass. Solid models are normally created as three-dimensional geometric shapes, but regardless of mass. Now, there's a process inside the 3D Studio Max that you assign mass to a solid model. And what happens when you assign a mass to solid model? It gains weight and it falls down. So on the top right-hand corner, you are looking at the right side view of the rocket. And at the very bottom, if you see, there is a black line. That black line represents the ground line. Okay, and rocket, as you can see, a little bit above, few meters above the ground. Okay, and when I add this mass to this rocket, it's supposed to fall down under the influence of gravity. Okay, and gravity on Earth, as you know, has a value of 9.81 meter per second squared. So this is going to, computer is going to do this automatically by if you just follow the instructions from the screen, and also those instructions are also on the Schoology. Written instructions are also on the Schoology if you follow them. So we're going to simply add the mass and see the effect of this on our solid model. And it's not going to fly right away. It's going to fall down actually on the ground line. Okay? And in order to do that, you have to just simply remember many of the assignments, animations that you create, simulations that you create, will require a solid mass. So you need to go find the dynamic Massfx toolbar first, and convert your solid model to dynamic rigid body. Now you're going to hear these terms a lot. Dynamic rigid body is the rigid body that under the influence of gravity and velocities and the multiple forces and so on, just like our real world. So we call these solid models dynamic rigid bodies, but there are other rigid bodies. For example, there's a kinematic rigid body. There's a static rigid body. Ground is considered static rigid body. Okay, is an example of static rigid body. This terminology directly comes from the 3D Studio Max. Kinematic rigid body is the one that, regardless of its own mass or other qualities or forces, you simply define the motion only. Okay, so that is some defined three-dimensional solid model that simulates the motion of an actual worldly solid model, but it does not actually is computed. Its weight and mass and other forces are not actually computed. In this particular case, we're going to convert this solid model into dynamic rigid body by just issuing a command. Dynamic rigid bodies are the most similar to real-world solid models, actual models, real-world objects that you enable the solid model on the digital solid model to gain weight and act like as a weight and under the influence of other forces such as gravity. Okay, so how do we do that? I suggest you to click in the screen anywhere outside and then click on the object again to see that object is surrounded by blue line that indicates that the object is selected. Now you need to move your cursor over the pull-down menu on the top. Okay, the ribbon on the top, very, very top. There are, like, if you count from file edit tool 3, 4, 5, 6, 7, 8. The 8 group of commands on the top is animation. So click on the animation. You will see the pull down menu items. Okay. And move your cursor on the video and take a good look at it. There are a number of things: load animation, save animation. You can save literally and load or save animations. First save them and then load them. Transform controls, position, and so on and so forth. And you move your cursor, okay, to Massfx, okay, and stop at the Massfx. Massfx, okay, will open to a new dialog box called rigid bodies. You move your cursor over. So you want to add Massfx, okay, to your solid model. That's why you need to stop by Massfx. Okay, you want to move your cursor over rigid bodies. Yes, we're going to choose a rigid body, but which one? As I mentioned to you before, dynamic rigid body, there's a kinematic rigid body, there's a static rigid body. And don't pay attention to other things at this moment. We're going to, after you do this, we're going to go and visit simulation later on and simulate the effects, okay? But first of all, we should do and assign the rigid body, dynamic rigid body. So object is already selected, solid model is already selected. So click with the left mouse button. And if you don't have a mouse, you're in trouble. You have to move, find a mouse or purchase one. I suggest you strongly buy your own mouse and bring it in your, with your laptop, in your backpack. It's very important. These are modern times. It's been a long time ago. I mean, these are literally modern times. That last 30 years or so, we have been using laptops, computers, mice, and everything, all the programs. And anytime I go to college in recent years, I just take it with me. So click on the dynamic rigid body. And all of a sudden, you see something changed. The solid model, the picture you have, particularly at the lower left-hand corner, there's a 3D view. It is more convenient for me. I want to explain it to you that I have 4 screens. The screen is divided into 4 equal parts, and I'm very comfortable with that because I like to see my rocket, the top view on the top left viewport, and right side view and front view at the lower left viewport, right side views on the top right, and lower right hand corner I have the 3D view. I'm very comfortable using this kind of viewport configuration. This can be changed, and we can have a single viewport or 2 viewports or 3 viewports, but literally I suggest you, for all practical purposes, you're going to need all 4 of them. So after assigning, okay, the dynamic rigid body, okay, dynamic rigid body becomes one of the properties of your solid model. It instantly learned that mass, okay, and there's a default value, okay, and at the same time, the command menu on the right hand side, the vertical command menu, started showing me different values. For example, on the command menu, I can see the Massfx rigid body appearing on top of the Pro Boolean. This is your browser. Inside the browser, okay, you have the Massfx. All the operations are actually recorded. And the Pro Boolean is what we did in order, all the operations required, okay, for the entire rocket. Everything we did geometrically. And the Massfx, okay, I'm just showing you by just clicking on the arrow on the top right-hand corner that the number of the things, okay, has been added automatically by just selecting selecting the Massfx toolbar. So basically, Massfx toolbar added initial velocity, initial speed, center of mass, and the mass transform. So for example, if you want to know where the center of the mass of the rocket is, click on it. You'll get to see the arrows right about 1/3 from the bottom up. And if you look at the top view, right at center, on the top view, on the right side view, approximately, because it's 3-dimensional, entire shape looks like, similar to, resembles a triangle, and center of the mass of the triangle is on 1/3. So center of the mass of this rocket, okay, or roughly 1/3 of the, approximately 1/3 of the rocket. Okay, so all of this, and there's initial velocity that we're going to add it later on, but basically Massfx, okay, rigid body has been added. Let's take a look at the other qualities, other properties. For example, under the physical properties, you will see the density of the rocket assigned automatically 0.5. 0.5, okay, for the density per square pounds per cubic inch, okay, when it is multiplied by the total volume of the mass, okay, it gives you 29,487 pounds, or approximately 29,488 pounds. Okay, that is the mass affected, added to your rocket. Now the static friction is added. There's always static friction, always dynamic friction. As it moves, there's going to be 0.3, and the bounciness also. So all of this, I want you to analyze those numbers because they are mathematically computed, calculated in the motion of your rocket. We plan to launch this rocket and send it, travel all the way to thousands of meters outside the Earth, okay, and come back. Okay, this is what we're planning to do. So if you bring down, okay, there's on the right hand side of this command menu, there's a slide bar, and then take a look at it, and there's there's something called advanced simulation, for example. You have the forces, but we don't need to adjust or change values, physical shapes. Okay, there are a number of, and when you click on the advanced, you will see the velocities are also can be assigned in X, Y, Z directions. Initial spin can be assigned again in X, Y, Z. So all of this, center of the mass, okay, and use pivot. All of this, all the information is accessible and and enables you to change them. Okay, so now that we did what we want to do, okay, we want to see the effect of it, whether it's going to work or not. And so what we're going to do, we're going to simulate this as simple. You can see it's like a few meters above the ground, the entire thing, okay? A few meters above the ground, and we're going to simulate it. So I'm going to move my cursor over the animation. Again, this is the 8 icon from the top left-hand corner. You click on it, okay? And go to the Massfx, okay? Find the rigid bodies, go back down from there, and utilities, okay? There are a number of, go to simulation, utilities has other qualities that you can find out, Open Dynamic Explorer and so on, show Massfx. But you can go to simulation and play simulation. And please pay attention to the rocket now, what's likely to happen. The rocket fell down. Did everybody see this? Very good. Well, we can do it again. I'm moving my cursor down and play button so that I turn it off. Okay, and go back to the beginning. Okay. Now, let's do this one more time. Go to animation, and under the animation Massfx, and go back to simulation and play the simulation. Let's do this, and one more time. Animation and Massfx. reset the simulation. We need to reset the simulation, so rocket is back to where it's supposed to be now. Okay, reset simulation. And let's go back to animation and mass effects, rigid bodies, simulation, and play the simulation. And rocket falls down. Rocket's on the ground and it's bouncing right now. You can see it. There's a barely visible bouncing, so we're going to have to reset this. We go to animation again, and same way, mass effects, simulation, and reset the simulation. Okay, so after a motion has been established, or desired motion, or portion of desired motion, you can bake, or you can fix, you can record that motion. But I don't want to do this one, because literally I want this rocket to launch it off and then come back and bake it later on. Okay, when you bake some emotion, it literally records frame by frame the entire motion. But the entire simulation is based on the calculations, mathematical and physical and engineering calculations. And at the end, once you accomplished your purpose, then you can record the motion, okay, so that you can make a video out of it, all right? So that's pretty much how it works. And in the meantime, don't forget to save your work. This is the most important part, and we should save every time we accomplish anything. Save your work, click on the save button, okay? So next thing I'd like to show you is that we're going to launch the rocket and actually watch how far it is going and so on. And to be able to do that, we need to be able to measure the elevation it's going on. We have no tools or no environmental clues right now to measure except that measuring tape. So I want you to also add a measuring tape, okay? That as the rocket takes off and starts its trip, the measuring tape should indicate how far it is going. So the first goal is 36,000 meters, 36 kilometers. Okay, it's not much. Another goal could be having the rocket go to 100,000 meters, perhaps. And where is the International Space Station? It's about 250,000 meters off the ground. So maybe we should have 3 measuring tapes, okay, marking those elevations. So that's going to help us to, if you add also measuring tapes around it, okay? So to do that, I'm going to go to create on the right-hand command menu, okay? And I'm in the create tab. Create tab will give you a helpers, okay, 1, 2, 3, 4, 5. The 5th icon from top right, it's a triangle shaped helper, so click on it. And there is a tape option. When you click on the tape option, it gives you the length of, okay, the tape, okay? So we're talking about 36,000, so I'm typing 36,000, okay? And I'm moving my cursor where on the black grand line where it's supposed to be, approximately on the left side of the right view. This is the front view, I'm sorry, front view of the, and I'm dragging, click and dragging, okay, up. In the meantime, I'm looking at it to the right, and I'm trying to make sure that it's 90 degrees, okay? So, as you can see, on the right-hand side, you can see the x-axis 90 degree, y-axis 90 degree, and the z-axis is 90 degree. And on XY plane, this line. So this is specified length of the measuring tape, and 36,000 meters indicators. So hit escape key, okay, and escape key, and click on the outside, on the air. Now we need that another tape. This time we need 100,000. So you go to the click on the tape button and change the number to 100,000. This is going to be indicator of measure of 100,000 meters. Okay. Again, do the same thing. Move your cursor to the right side of the rocket in the front view and drag it up. And try to do the same thing carefully. I'm dragging and I'm going to let it go. Okay, and those numbers, I didn't like it. I'm going to erase this. I'm going to do this one more time, more carefully this time, because it has to be perfectly 90 degrees. Okay, so I'm just moving our cursor, and I'm trying to find the 90-degree angle. I have it. Yes, there it is. And hit the escape key and click outside. Okay. As you can see, I have now two measuring tapes, and one of them is 36,000, indicating 36,000. The other one is indicating 100,000. Okay. And finally, I want to add another one, another measuring tape, and this time I want to mark the International Space Station elevation, which is 250,000, okay, approximately. So I'll click on the tape again, and this time I'm going to click inside the length of the tape. This time it's going to be 250,000, okay. For that, I want to move my cursor over the lower left-hand corner, which is indicating the left view. Okay, I'm going to move it and see if I can carefully adjust this 90 degree to 90 degree. Okay. All right. So I think it's a little bit off. I'm going to do that one more time. And starting from the ground on the right-hand side, I'm on the left view actually, and being very careful about the angles being perfectly. Okay. So this is a measuring tape, okay, for indicating the elevation of 250,000. I'm going to save this first. I'm going to escape first, okay? Press outside, all right? And then file save. Okay, so in the next class, in the next session of the video, in the next video, I am going to assign an initial speed, okay? And I will try to explain to you what's happening, it's likely to happen, and so on after that. And we'll see how the rocket is going to behave. But so far, I need you to accomplish this session, that what we did so far. Add the Massfx toolbar and make sure that you add the properties of mass to the rocket, and 3 measuring tapes indicating 3 different elevations. And next class, I will assign initial velocities and then discuss this issue. There's a very technical issue about the initial velocities that I want to discuss with you next class. Have a great day. Bye. Thank you very much for your attention.